Welcome back, everyone. Today, I want to talk about something that comes up in my conversations with patients, and honestly, with friends and family, almost every single week now. And it goes something like this. Someone comes in and they say, "Doc, I'm sleeping 8 hours a night. I'm eating reasonably well. I'm not drinking too much. I'm not doing anything crazy. And yet, every single morning, I wake up feeling like I never went to sleep at all. I'm exhausted. I'm dragging. By 2 o'clock in the afternoon, I just crash." And here's what's interesting. These aren't people who are living irresponsibly. These are often highly motivated, disciplined individuals. They're professionals, athletes, parents juggling everything at once. And still, this persistent, grinding exhaustion just won't let go. Now, the knee-jerk answer for a lot of people is just more coffee, more caffeine, maybe an energy drink. And I get it. When you're tired, you reach for what's fast. But here's the thing. Caffeine doesn't actually fix the problem. It just masks it. It's like putting a piece of tape over your check engine light. The light stops blinking, but the engine is still struggling. So what is actually going on? Well, today I want to go deep on this with you, because the real answer, the actual root cause of this kind of chronic, persistent fatigue, often isn't about your sleep hygiene or your coffee intake or your stress levels alone. It goes all the way down to the microscopic level. It's happening inside your cells. Specifically, it comes down to tiny structures called mitochondria. And over the next 20 minutes or so, I'm going to walk you through what mitochondria actually are, why they become dysfunctional over time, and, most importantly, 5 specific science-backed strategies you can start using to essentially regrow and restore your cellular energy system. No gimmicks, no magic pills, just solid biology and practical strategies. Let's get into it. Okay, so let's start at the beginning, because I want to make sure we're all on the same page before we dive into the strategies. Mitochondria. You've probably heard the word. Maybe you remember it from high school biology. The powerhouse of the cell, right? That classic phrase. And it's actually a pretty accurate description, even if it sounds a bit oversimplified. Here's what's actually happening inside you right now. Every single cell in your body, and we're talking about roughly 37 trillion cells, almost all of them contain these mitochondria. And their primary job is to take the food you eat, the carbohydrates, the fats, the proteins, and convert those raw materials into a form of energy your body can actually use. That energy is called ATP, adenosine triphosphate, and it is the currency that powers literally everything you do, every thought you think, every heartbeat, every muscle contraction, every time your immune system fights off an infection. All of it runs on ATP. Now, here's where it gets really interesting from a clinical perspective. The number, size, and efficiency of your mitochondria are not fixed. They change, constantly, based on how you live. Think of your mitochondria like a fleet of power plants. When they're working well, you've got full capacity, strong output, efficient energy, resilience. But over time, through poor lifestyle habits, chronic stress, bad sleep, inactivity, and just the natural aging process, these power plants start to deteriorate. Some of them malfunction. Some of them produce energy less efficiently and generate more exhaust in the form of what we call reactive oxygen species or oxidative stress. And when you have too many damaged, inefficient mitochondria and not enough healthy ones, you feel it. You feel it as fatigue, as brain fog, as that 2 p.m. slump that no amount of willpower can push through, as the feeling that you're somehow running on a fraction of your former energy. Now here's the genuinely exciting part. And this is what I really want you to take away from today. Your body has a built-in process for renewing and regenerating mitochondria. It's called mitochondrial biogenesis. Bio meaning life, genesis meaning creation. Literally the creation of new cellular life. And there is a complementary process called mitophagy. Think of it as mitochondria eating, where your body identifies the old, damaged mitochondria and clears them out, making room for fresher, more efficient ones. The question is, are you living in a way that triggers these renewal processes, or are you living in a way that suppresses them? That's exactly what we're going to address today. 5 strategies, all evidence-based. Let's go through them one by one. Strategy number 1, exercise. And I know, bear with me, because I realize that's not a revolutionary idea. But the way I want to frame it for you today is a little different. I don't just want to say, go exercise. I want to explain exactly what's happening in your cells when you move, and why the type and frequency of your training matters so much more than you might think. When your muscles contract during exercise, especially intense exercise, they rapidly deplete their local energy supply. And that drop in cellular energy triggers what we call a metabolic alarm signal, specifically through an enzyme called AMPK. Think of AMPK as a cellular distress signal. When energy drops, AMPK sounds the alarm. And what does that alarm trigger? It activates a master regulator called PGC1 alpha, which I like to think of as the construction foreman for new mitochondria. PGC1 alpha essentially tells your cells, we need more power plants, build more mitochondria. So, exercise, at its cellular core, is literally a signal to manufacture new energy infrastructure. That's remarkable when you think about it. Every time you push yourself physically, you're essentially placing an order for more efficient, more numerous mitochondria. Now, there are 3 specific types of training that work through slightly different biological pathways, and ideally, you want all 3 in your weekly routine. The first is high-intensity interval training, HIIT. This is the most potent acute trigger for mitochondrial biogenesis. The idea is short bursts of very hard effort. We're talking about 2 to 3 sessions per week, with 4 to 6 intervals each. Each interval lasts somewhere between 30 seconds and 2 minutes of genuinely challenging effort. Not just uncomfortable, but legitimately hard. And then you recover, and you repeat. The reason this works so powerfully is that it creates a dramatic temporary energy drop inside the muscle cell. And that sudden crash in energy levels sends an extremely strong signal through AMPK and PGC1 alpha to build more mitochondria. Now, I want to be very clear about one thing here, because I see this mistake a lot. The goal is not to destroy yourself in the gym. Patients sometimes come in and they're proud of how wrecked they feel after a workout. But if you're training to the point where you're completely depleted for days afterward, you're actually impairing the rebuilding process. You need to stress the system enough to trigger adaptation, but you also need to recover enough to actually build. The second modality is Zone 2 aerobic training. This is steady, moderate-intensity cardio, a brisk walk, a light jog, easy cycling, something where you can hold a conversation, but you're definitely working. This zone of exercise has become really popular in the longevity community, and for good reason. It's exceptionally efficient at training your mitochondria to burn fat rather than sugar, which is the hallmark of what we call metabolic flexibility. For Zone 2, aim for 3 to 5 sessions per week, each lasting between 30 and 60 minutes. This is your aerobic foundation. It's lower intensity, yes, but the cumulative mitochondrial benefit over time is enormous. And the third is resistance training, strength training 2 to 3 times per week, major muscle groups. Now, here's what I tell my patients who are newer to lifting. Don't worry about how much weight you're moving. Focus completely on form first. Perfect execution on lighter weights builds just as much mitochondrial stimulus as sloppy execution on heavy weights, and with far less injury risk. As we age, one of the key challenges is preserving the mitochondrial density inside our muscle tissue. Muscle isn't just important for strength, It's one of your primary metabolic organs. Maintaining muscle mass through resistance training is one of the most powerful long-term strategies for keeping your cellular energy system healthy. Here's my overarching philosophy on exercise for mitochondrial health. Consistency always beats peak intensity. I've seen many patients who do these massive, brutal workouts once in a while. They go all out, they're exhausted for a week, and then they don't train again for 2 weeks. That pattern is far less effective from a biological standpoint than someone who does moderate, steady work 5 or 6 days a week with appropriate intensity. Frequent, regular signals through AMPK. That's what the research actually supports for long-term cellular renewal. All right, strategy number 2, and this one I genuinely wish more people understood at a mechanistic level, because I think it would fundamentally change the way we think about sleep. We tend to think about sleep as passive, as doing nothing, like it's just downtime, while the important parts of life happen when we're awake. But from a biological standpoint, sleep is anything but passive. Sleep is, in many ways, the most metabolically active and critically important part of your entire 24-hour cycle. Here's what's actually happening when you sleep. Your brain is clearing out metabolic waste products that accumulate throughout the day. Your immune system is recalibrating and strengthening. Your muscles are repairing the micro-tears from today's activity. And, crucially for our conversation, your mitochondria are undergoing deep maintenance. That process I mentioned earlier, mitophagy, the clearing out of damaged mitochondria, happens predominantly during sleep. Think of it like a waste management crew that only comes out at night. During the day, your mitochondria are busy producing energy. But while you sleep, the maintenance team moves through, identifies the organelles that are damaged or inefficient, dismantles them, and recycles their components. This clears the decks for fresher, more functional mitochondria to take over. Now, when you consistently get poor sleep, you know what happens? That maintenance crew never shows up, or it only gets to do a fraction of the work. The damaged mitochondria accumulate. They're producing energy less efficiently. They're generating more oxidative stress, and you feel it the next day, and the day after that, as a kind of lingering fatigue that just doesn't resolve. We actually have a term for this accumulation of cellular damage over time from chronic poor sleep: inflammaging. It's a portmanteau of inflammation and aging, and it describes exactly what happens when chronic low-grade cellular inflammation, driven in part by poor mitochondrial quality, accelerates the biological aging process. So practically speaking, what does this mean for you? First, target 7 to 8 hours per night. Not 6, not I can function on 5. 7 to 8 consistently. Second, your sleep environment matters enormously. Your bedroom should be cool. Around 67 to 68 degrees Fahrenheit is actually the sweet spot that most sleep research points to. Cooler temperatures facilitate the deep sleep stages where the most profound cellular repair occurs. Dark and quiet go without saying. But I want to specifically call out phones and screens. The blue light from screens suppresses melatonin, which is the hormone that signals to your body and your mitochondria that it's nighttime, repair time. So if you're scrolling through your phone until midnight, you're actively sabotaging that cellular service window. And third, and this is something I really emphasize with my patients, consistency of sleep schedule is arguably as important as duration. Going to bed and waking up at the same time every day, including weekends, keeps your circadian rhythm tight and predictable. And your mitochondria, as we'll talk about in a moment, are deeply synchronized to your circadian biology. Think of chronic sleep debt as a cellular service backlog. Every night you skimp on sleep, you're adding more damaged mitochondria to the queue. And eventually, that backlog starts to show up as systemic fatigue, cognitive impairment, and accelerated biological aging. Sleep is not a luxury, It is maintenance. Okay, strategy number 3. And this is one that genuinely surprises people when they first hear it, because it sounds almost too simple. But the biology behind it is actually quite elegant. Morning sunlight. Now, before you roll your eyes and say, "Doc, you're telling me to go outside in the morning," let me explain why this matters. Because it's not just about vitamin D or mood. It has a direct and measurable effect on your mitochondrial efficiency and energy output throughout the day. Here's the mechanism. Deep in your brain, in a region of the hypothalamus, you have what's called the suprachiasmatic nucleus. It's your body's master clock. It coordinates and synchronizes essentially every biological process in your body to a roughly 24-hour cycle, what we call the circadian rhythm. And your mitochondria are not exempt from this timing system. They have their own circadian cycling. During the night, the repair phase, they're primarily in maintenance mode. They're clearing out damaged proteins and membranes. They're rebuilding. They're doing housekeeping. Then, as morning approaches, they're supposed to transition into active energy production mode for the day ahead. The trigger for that transition? Light. Specifically, natural sunlight entering your eyes shortly after waking. When natural light hits specialized photoreceptors in your retina in the morning, it sends a clear, unambiguous signal to your suprachiasmatic nucleus. It's daytime. Time to switch to active mode. And that signal cascades down to your mitochondria, telling them to stop the repair processes and ramp up ATP production for the day. So when you don't get that morning light signal, when you wake up and immediately go to an artificially lit office, or you pull the blackout curtains and avoid sunlight for the first few hours of your day, your mitochondria essentially don't get the memo. They're still trying to run maintenance protocols while you're demanding peak performance from them. And that mismatch is part of why so many people feel sluggish and off for the first half of their day. The practical prescription here is beautifully simple. Spend 5 to 15 minutes in direct, natural sunlight within the first hour of waking. You don't need to stare at the sun. Just be outside. Let the light reach your eyes. Walk to get your coffee. Sit on your porch or balcony. Take a short walk around the block. The exact activity doesn't matter. The light exposure does. If it's a cloudy day, extend that exposure to 20 or 30 minutes. Overcast skies still deliver far more light signal than indoor lighting, but you need a longer duration to get the same effect. This is such a low-effort, high-reward behavior that I honestly can't think of a reason not to try it. 5 to 15 minutes. And it's not just your mitochondria that benefit. Your cortisol rhythm becomes more anchored, your melatonin production in the evening becomes more reliable, and your overall sleep quality typically improves as well. It's a beautiful example of how a very simple, free, accessible intervention can have meaningful biological effects, all the way down to the cellular level. All right, strategy number 4. And this one takes us in a direction that I find absolutely fascinating. The intersection of gut health and mitochondrial health. Because it turns out, these two systems are much more tightly connected than we used to think. I want to talk about a compound called urolithin A. Now, urolithin A is not something you eat directly. It's a compound that your body produces, but only when the right bacteria in your gut process certain plant compounds called alagitannins. And where do you find alagitannins? In pomegranates, in walnuts, in certain berries like raspberries and strawberries. So the pathway looks like this. You eat pomegranates or walnuts. The alagitannins reach your large intestine. Specific gut bacteria metabolize those alagitannins. And the byproduct of that process is urolithin A, which then gets absorbed into your bloodstream and does something really remarkable in your cells. Urolithin A is a potent activator of mitophagy. Remember that cellular cleanup process we talked about? Urolithin A essentially supercharges it. It helps the body more efficiently identify and clear out damaged, dysfunctional mitochondria, which allows the system to refresh itself with newer, more efficient ones. In clinical research, it's been shown to have meaningful effects on markers of mitochondrial renewal and cellular health. Now, here's the complication, and this is where I want to be really honest with you, because I think it's important. Not everyone can produce urolithin A, even if they eat all the right foods. Studies suggest that only about 30 to 50% of people have the specific gut bacterial composition necessary to carry out that conversion from elagitannins to urolithin A, which means that somewhere between half and two-thirds of people, even if they're diligently eating pomegranates and walnuts and berries every day, are not actually generating meaningful amounts of this compound. This is what I call the microbiome gap, and it's a genuinely important clinical reality that often gets glossed over in the popular wellness conversation. The idea that you can just eat the right foods and automatically get all the benefits assumes a microbiome diversity and capacity that many people simply don't have, particularly after years of antibiotic use, poor dietary history, or other factors that can disrupt the gut ecosystem. So what can you do about this? Well, one evidence-based approach is a directly supplemented form of urolithin A called MitoPure, which has gone through clinical trials. This bypasses the gut conversion step entirely. You're getting the compound directly without needing your gut bacteria to produce it for you. The clinical data is meaningful. Studies show that 16 weeks of consistent MitoPure supplementation can increase markers of mitochondrial renewal by approximately 39%. And importantly, this is very different from an energy drink or a stimulant. MitoPure doesn't give you a short-term energy spike. It's supporting the long-term structural renewal of your mitochondrial population. Think of it as infrastructure investment, not a quick fix. I want to be balanced here. Supplementation is one tool in the toolkit, not the whole toolkit. And it works best when combined with the lifestyle strategies we're discussing today. But for people who have been eating well and still feel like they're not getting the cellular renewal benefits they'd expect, this microbiome gap is worth knowing about. And it's worth discussing with your physician. Also, from a diet perspective, regardless of whether you supplement, regularly eating foods rich in polyphenols and elagitannins is still beneficial. Pomegranates, walnuts, raspberries, and strawberries are excellent choices. Even if your microbiome can't convert everything to urolithin A, these foods confer enormous benefits through other anti-inflammatory and antioxidant pathways. Feed your gut. Feed your mitochondria. They're talking to each other more than we ever knew. Strategy number 5. And this is the one I find myself talking about most often in clinical conversations, because it addresses something that is genuinely new to human biology, at least in evolutionary terms. We are, for the first time in the history of our species, living in a state of constant nutritional abundance. Think about that for a moment. For virtually all of human evolutionary history, access to food was not guaranteed. There were periods of feast and periods of famine, periods of eating and periods of going without. And our biology, our cellular biology, adapted to that rhythm. The periods of not eating weren't just tolerated, they were expected. They triggered critical repair and maintenance functions at the cellular level. But now, for many people in the developed world, we're eating from the moment we wake up to almost the moment we go to sleep. We're perpetually in what's called the fed state. And when your body is constantly processing incoming nutrients, it doesn't switch into repair mode. It's too busy with energy storage and processing. Here's the cellular mechanism. When you eat, your blood insulin levels rise. Insulin signals your cells to take up glucose and store energy. That's its job. But elevated insulin also actively suppresses the signals that trigger mitophagy, that cellular cleanup process we keep coming back to. Conversely, When insulin drops, as it does during a meaningful fast, it acts as one of the primary biological signals to initiate cellular cleanup. The body essentially says, no new resources coming in, time to clean house, let's recycle the old broken parts and make the system more efficient. So how do you practically create this fasting window? There are two main approaches. The first is reducing your overall caloric intake, something around a 25% reduction, which tends to lower the average insulin burden across the day and create more opportunities for repair signaling. The second, and often more practical approach, is time-restricted eating within an 8 to 10 hour window. So for example, you eat your first meal at 9 in the morning and you finish your last meal by 6 or 7 in the evening. That gives you a 14 to 16 hour fasting window overnight. During those 14 to 16 hours, insulin drops, and your body gets a substantial window to run those mitophagy and cellular renewal processes. Now here's where it gets really interesting from a circadian biology standpoint, because this ties directly to everything we've been talking about today. The timing of your eating window matters, not just the duration. Research consistently shows that eating earlier in the day, aligned with daylight hours, produces significantly better metabolic outcomes than eating the same amount of food later in the evening. Your digestive organs, your liver, your metabolic enzymes, they all have circadian rhythms too. They are more efficient and more synchronized during the earlier part of the day. So ideally, you want your eating window to run something like 8 a.m. to 6 p.m., not noon to 10 p.m. And specifically, and I really want to emphasize this, avoiding late-night meals is critically important. When you eat a large meal, especially one high in refined carbohydrates or processed foods, close to bedtime, you're spiking insulin precisely when your body is trying to transition into overnight repair mode. You're essentially flooding the factory with raw materials right when the maintenance crew is supposed to be coming in. That late-night eating disrupts your mitophagy window. It delays the cellular cleanup, and over time, it contributes to that same accumulation of dysfunctional mitochondria that we've been talking about throughout this conversation. So the simple principle here is, eat earlier, fast longer. Align your nutritional intake with your biological rhythms. Let your gut rest. Let your master clock and your mitochondria do their repair work without interference.
Don't forget to hit that subscribe button and join the journey.
All right, let's pull this all together. We've covered a lot of ground today, and I want to leave you with a framework that makes this feel actionable rather than overwhelming. We talked about 5 strategies. Let me walk through them one more time quickly. Strategy 1, exercise. Use HIIT 2 to 3 times per week to create strong mitochondrial biogenesis signals. Use Zone 2 cardio 3 to 5 times per week to build metabolic flexibility. Use resistance training 2 to 3 times per week to preserve muscle mitochondria as you age. And always prioritize consistency over intensity. Strategy 2, sleep. 7 to 8 hours consistently. Cool, dark, quiet environment. Same bedtime and wake time every day. Protect this window. It's when your cellular maintenance crew does its best work. Strategy 3, morning sunlight. 5 to 15 minutes of natural light exposure within the first hour of waking. This synchronizes your master clock, which cascades down to your mitochondria, shifting them from nighttime repair mode into daytime energy production mode. Strategy 4, urolithin A. Eat polyphenol-rich foods, pomegranates, walnuts, berries. Understand that if you have the right gut microbiome, your body will produce urolithin A, which powerfully activates mitophagy. If you don't, and many people don't, a clinically studied supplement like MitoPure offers a direct pathway to meaningful cellular renewal over time. Strategy 5, strategic fasting. Time-restricted eating within an 8 to 10 hour window. Eat earlier in the day, avoid late-night meals. Let insulin drop during the overnight hours so your body can run its cellular cleanup protocols without interference. Now, I want to close with something important, because I think the wellness world sometimes sets unrealistic expectations. These strategies are not a quick fix. You are not going to overhaul your mitochondrial health in a week. The research is actually quite clear that meaningful improvements in mitochondrial function, cellular renewal rates, and biological energy production happen over months of consistent daily choices, not days. But here's what I will tell you, based on both the research and what I hear from patients who commit to these changes. You often begin to feel the difference much sooner than you might expect. Within 2 to 4 weeks of consistent implementation, many people report noticeably improved stamina, clearer thinking, and more stable energy throughout the day. The brain fog starts to lift. The afternoon crashes become less severe. Mornings feel a little more manageable. And then over months and years, the deeper biological changes compound. Your cellular age, which is distinct from your chronological age, begins to reflect the investment you're making. Your energy levels are not a fixed trait. They are not simply who you are. They are a direct, real-time reflection of how efficiently your mitochondria are functioning right now. And the extraordinary thing about mitochondria is that they respond to your choices. Every workout, every good night of sleep, every morning you step outside into the sunlight, every meal you finish before 7 p.m. Each of those is a signal, a message to your cells. Build more, repair, renew. That's the conversation you can start having with your own biology, starting today. I hope this was useful. If you have questions, drop them in the comments. I do read them, and they genuinely shape the topics I cover next. If this kind of deep dive science content is helpful to you, please consider subscribing, because we're going to keep going deeper into this territory. Take care of your cells. They're taking care of you.